Great. Thanks, Megan. Thanks everyone else for as well for joining this afternoon, this morning or this evening, depending where you're attending from in the world. And appreciate you being here. And hopefully, as Megan said, through this webinar process that we have, you're able to pick up something, learn something along the way, take that back and share it with others as well. So a little bit about myself. As Megan mentioned, I'm the director of the software validation services and strategic planning services at CSOLS. I've been in the industry doing software system validation for just over 22 years now, spanning large pharma, CROs, vaccines, across the GLP, laboratory manufacturing, R&D spaces, a little bit of clinical here and there along the way. I've done a lot of implementation of laboratory and enterprise systems, specifically with laboratory, that would be informatics rather. So any of the LIMS, chromatography data systems, a lot of your benchtop software instrument type systems. Also been involved with qualifying infrastructure and networks along the way, and performing laboratory system and data integrity audits. So every once in a while, I think when I look at a system and talk to a client or a customer, I'm finding more and more that I've seen quite a bit of the systems out there, which is kind of scary to think about, but I'm glad to be doing what I'm doing and hopefully help you in today's presentation understand that shift from traditional CSV to what's coming down the road with computer software assurance. So a little bit on the agenda, plan to cover with you today is I'll start with a little brief history of computer system validation, so we can see kind of how we got to where we are today, kind of help set the stage and maybe understand a little bit as to what's changing going forward. And not only changing, but also help us see what similarities and what's going to stay, right? So look at where we've been to know where we're going, look at the current landscape of today to see what has been driving the move to CSA. Then focus on what is computer software assurance. It's made up of many things, biggest of which are critical thinking. We'll talk about how testing's changed a little bit with scripted and unscripted testing, the benefits of CSA, and it's also good to touch on a little bit of what it doesn't mean moving to CSA. And what I mean by that is what's really going to stay the same, right? It's kind of help see that it's not this big, huge overhaul of a change of direction for us. But then finish up with how do I prepare for CSA, and some things that we've seen here at CSOLS and the work we've been doing related to CSA over the last year or so, and have helped share some of that information with you, and then summarize it quickly at the end. And as Megan said, please, if questions come up along the way, please make sure you track them or put them into the chat feature so we can loop back around at the end, and hopefully I can answer those for you. So starting with our brief history of CSV, I'm just go back to, and as I move through these dates, maybe you're familiar with some, maybe you aren't, but these are some of the key ones that I've found that have really set the stage for what happened with software validation along the way. So we go back to 86 to 87, those couple year time frame. There was a radiation therapy machine called the Therac 25, and down in the bottom right corner is a picture of that instrument. Now, I know I've been doing validation for a while, but I was not doing it in 86 or 87. Probably didn't even know what validation was at that point in time. But out there was this piece of machinery called Therac 25 that was sending radiation in to kill cancer. But actually, there was a software bug that unfortunately actually killed some individuals. There were 5 patients that were ultimately impacted, 4 of which died due to over-radiation, and a 5th that had serious injuries resulting from that. What the bug did in the software was it well, I should say what it didn't do is it didn't restrict the amount of radiation that was being released, right? And the way that the instrument was built, there was no physical shutoff at the time. It was all controlled through the software, which if there's a bug where you can't shut it off, that's obviously a bad situation. So around that same time, the FDA released some guidelines on general principles of process validation. And so there was this early start with validation in general revolving around process, and then there's this killer software bug that gets into more of software. And through those next few years, there were some more issues with non-compliances in computerized systems. So in '91, the FDA banned import of products based on these non-compliances. So things were really starting to come to the surface as computer systems at that point in time were becoming, if you will, for all things considered, more advanced, right? And being put into use more in the life sciences and pharmaceutical medical device industry. So in '92, Annex 11 came out in the EU, really dealt with more specifically with electronic systems, software, and the processes around that, how to control that, how to work with it. In '95, GAMP came out, the first version of GAMP. If you're not familiar with GAMP, it's Good Automated Manufacturing Processes. And that first version came out that really kind of set the stage for what we now have, and I'll get to it here on the next slide, but what we now have is GAMP kind of being that industry standard approach to software validation, but it really focused in on that first version on manufacturing systems and eventually evolved, right? In '97, the next big movement was Part 11 was released as a federal regulation. So now we actually have something that is a law, something that is required for the FDA regulated industry. GAMP was more of a guidance and guideline. Part 11 is the first regulation that really gets into electronic records, electronic signatures, speaks about validating for making sure the data is reliable, reproducible, readily available. That goes on for a few years. GAMP is being released along the way, but in 2001, GAMP version 4 comes out, and the big thing with version 4 is that it introduced software and hardware categories, right? So, now we're moving through. Okay, we've realized there's issues with software. We look at procedures to put in place. We look at more specifically electronic records and signatures. GAMP 4 comes along and says, hey, let's look at systems based on their category. So again, if you're not familiar with GAMP, they introduce in GAMP 4 5 categories ranging from infrastructure systems up to custom or bespoke systems. And it starts to introduce a risk-based approach to not treat every software system the same way, right? You can do variation based on complexity, criticality, these hardware and software categories. 2004, the FDA formally endorses a risk-based approach in what you see there, which does include the title risk-based approach, but it was the pharmaceutical CGMPs, the current GMPs for the 21st century. So that's when they actually endorse that, okay, let's start taking a more risk-based approach and figure out how to treat things just slightly differently based on risk. And then in 2008, GAMP version 5 comes out. That's the most current version of GAMP, considered the industry standard for software validation as it is today. The big thing with GAMP 5 is it got even more into a risk-based approach, introduced and I guess reintroduced, but also it took a little bit of a different swing on risk assessment and doing, and I'll get into this later in the slide presentation, but kind of the FMEA approach on how you not only categorize the system, but then look at the risk associated with each category. Validation has really evolved along the way, going from, hey, we just have problems with software, we should make sure software works, up to where we've been the last few years of, it's this type of system, this category, this level of risk, we do this based on this level of risk, and it's really well defined. And it's so we've come a long way in a fairly short period of time. So our current CSV landscape is all this, right? So I put this word cloud out there because everything in there is all part of CSV, right? When you talk about validation, chances are you're gonna, some document somewhere in your validation package is going to have these words, right? And there's just a lot that's involved. And the reason I put this up there is, one, to recognize there's a lot that goes into CSV, but then as we move toward what does CSA or software assurance mean, it'll kind of help draw back to what parts of all these terms are still going to continue, and what some of these terms might change a little bit, right? So it's kind of a visual capture of our landscape. And when we talk about validation, the way we're looking at it right now, I pulled this, paraphrased this from the FDA, that first statement there, and I tried to go back to figure out where I pulled this from specifically, and unfortunately I couldn't find it, but it is paraphrased from an FDA guidance document. That really what validation is it's that confirmation, and really through objective evidence. When you think about software validation, most people think of binders and binders of documents, just lots of documentation, right? I think that tends to be the most common thought, that and, oh, it takes forever, right? I think those are the two prevailing thoughts that I've seen in working the time in the industry. So it's that confirmation through objective evidence, that software we're using in our laboratory, so LIMS, chromatography, benchtop, that software conforms to user needs and intended uses, and it's consistently fulfilled over time, right? So if you could kind of encapsulate validation into a